Good morning, boys. In this video, we are going to discuss nuclear fusion, condition necessary for nuclear fusion, stellar energy, and hydrogen bomb. First, nuclear fusion. Nuclear fusion is a combination reaction when two lighter nuclei combine together to form a heavier nucleus and release enormous amount of energy. This process is known as nuclear fusion. In nuclear fusion reaction, the mass of daughter nucleus is formed during nuclear fusion is sum of the mass of two parent nuclei. This difference in mass is called mass defect. Example, 4 hydrogen atoms combine together to form one helium nuclei and release energy. 1H2 is an isotope of hydrogen named as deuterium. The energy released in each fusion is 3.84 into 10 power minus 12 joule. The mass of atom is converted into energy based on the Mohs energy relation E equal to mc squared, which is proposed by Einstein in 1905, where E equal to energy, m is mass of velocity, c is velocity of light. Then, condition necessary for nuclear fusion. In Earth atmosphere contain very less amount of hydrogen. Nuclear fusion is not undergo in normal temperature and pressure. Nuclear fusion is possible only at extremely high temperature from 10 power 7 to 10 power 9 Kelvin, and it requires very high pressure to push the hydrogen atoms come closer to fuse each other. This reaction also called thermonuclear reaction. So, nuclear fusion reaction occur only in high temperature and pressure. It does not occur in normal room temperature. Then, stellar energy. Star and sun emit a large amount of energy in the form of heat and light. This energy known as stellar energy. How does this stellar energy produced? Where does this high energy come from? Sun and all the stars contain a large amount of hydrogen. The surface temperature of sun and other stars are very high. This very high temperature is sufficient in nuclear fusion reaction to induce the fusion reaction of hydrogen nuclei. The fusion reaction takes place in the core of sun and other stars that result very high amount of energy is released. This energy is called stellar energy. Next, hydrogen bomb. Hydrogen bomb is made based on the principle of nuclear fusion. Hydrogen bomb is always designed inbuilt atom bomb because this structure help hydrogen bomb, which creates high temperature and high pressure required for nuclear fusion reaction when hydrogen bomb is exploded. Fusion takes place in hydrogen core and leads to release very high energy in uncontrolled manner. Hydrogen bomb released high energy than atom bomb. Then difference between nuclear fission and nuclear fusion. Nuclear fission reaction is the process of breaking the heavy nucleus into two smaller nuclei. Fusion reaction is combination of two lighter nuclei to form one heavier nuclei. In nuclear fission reaction, high temperature is not required for initial reaction. In nuclear fusion reaction, very high temperature is required for initial reaction. Nuclear fusion is a chain reaction. Nuclear fusion is not a chain reaction. Nuclear fission is carried by bombarding a heavy nucleus with neutron. In nuclear fusion reaction, two lighter nuclei combine in very high temperature. A large amount of energy is released in nuclear fission reaction. In nuclear fusion reaction, energy is released several times greater than nuclear fission reaction. Splitting of uranium is an example of nuclear fission reaction. Combination of hydrogen nuclei to form helium nuclei in sun and stars is an example of nuclear fusion. The product formed as a result in nuclear fission are radioactive and harmful. The product formed as a result nuclear fusion are not radioactive and not harmful for human being.